I'm not going to spend a crap load of time on this because we did talk about electronic EEVs. Electronic EPRs are the same. They're literally just bigger versions. All right? They don't do anything different. They're just polar motors that turn. Right? That's all that bipolar motors that turn. Excuse me. When we're talking about electronic EPRs, we're generally talking about a CDS valve. It's not the only one, right? But it's overwhelmingly the most popular, right? We see this valve used the most, so that's really why I'm calling it out, right, to discuss it.
That's great.
There's a few components about this CDS valve that become confusing that I'm going to try to clear up, make this a little cleaner for you in your mind. One of the biggest things when I think of CDS valves, I divide them into two types. It's really the easiest way to do this. It will clarify everything for you if you do this. All right? My 2, 4, and 7 are sizes of these valves. Right? Just like that orifice was our 32nd of an inch, right, on the EEVs. Okay? The 2, 4, and the 7 are like that. I don't know what they relate to. I assume it's some type of drill bit, a spooling, hell, I don't know. It's not eighths, and it's not millimeters. I did look at both. None of them make sense. But nonetheless, 2 is the smallest, 4 is the next biggest, 7 is the next biggest. We just know that's the order they're going to go in. On the big category, I've got 9s, 16s, and 17s. All right? If I think of all these CDS valves as either being small valves or large valves, then I don't have to remember 6, I only have to remember 2.
Yeah.
Right? Because everything's the same for the small valves, everything's the same for the large valves. Makes it a lot easier, right? The key components that I need to remember when I'm troubleshooting this, we talked about this with our EEVs. I can ohm across the motor windings, tell me if I'm open, I'm short, or if I have the right resistance or the wrong resistance. All of my small valves are 100 ohm. Okay? All of my large valves are 75. Okay? If I keep that designation, there's one piece I don't have to hang on to anymore. The other is number of steps. All right? Every small valve that I have is 2,500 steps. Every large is that weird 6386 number. All right? But they're all that. So I don't have to remember, is this valve a 2,500 or not? Just remember, is it a small valve or a large valve? Okay, a little simpler.
Yep.
One other thing I just thought was interesting, on resolution, I did the math on this, and just fascinating. It's 3.6 degrees of rotation per step. There's 360 degrees in a circle. That's 1/100th of a turn. Comes out very evenly, right? Kind of cool. So 2,500 steps means I have 25 rotations from stop to stop in that valve.
So, and then with the 6386, it has a .002.
63 steps per stop to stop.
Much more control.
Rotations. Yeah, 63 rotations.
Yep. Just kind of cool.
No, that is very interesting. They're not as dumb as they look.
All right. Another interesting note here on my SMA 12, when I'm testing these valves, I can choose my speed, right, that I selected to drive that valve open and close. Both of them run from 200 to 400.
You could literally time how long you're holding that button for
Correct.
the steps and do the math to say, if I want exactly 50%, I can hold
Yep.
it for this.
So
No, we're not.
once again,
We're not gonna do part of
you
it.
can read this, it's all in there, but this is like a 41-page document, right? You know, just finding these critical things and sticking them in there. Just highlighting those kind of important things. So what Ian was just talking about is right here on full motor transit time, that is stop to stop, how long it takes it to go that far,
At
all right?
200.
Wow.
Yep, that 200. So if I set my SMA 12 to 200,
Yep.
and I'm closed and I run this thing open 6 seconds, I'm pretty damn close to 50%. All right, so this is, I got 4 wires, right? And I'm always trying to figure out, because I'm standing there looking at it going, is this thing broke or not? Is it sending out the right control voltage or not? And I'm sticking my meter on there and none of it makes any damn sense. what's happening. All right, so I wanted to cover this part of it. There's only 4 steps on a CDS valve, all right? There's only 4 steps. I only have 4 wires. That means I'm gonna use every combination of those 4 wires one time. Okay? That's gonna be that's how my steps work. All right? This is the little cheat sheet on which ones in which order do they like. All right? Do I send power out? So this is my controller telling this to my valve. This is not my valve. My valve is responding because that voltage is coming in, but this is my controller going out. All right, my controller is telling this valve to open, then it's going to cycle through, sending power on black and red very quickly, then white to red very quickly, then white to green very quickly, and then black to green very quickly. That's going to tell it to open. All right, to reverse and close, it will work from 4 to 1 instead of 1 to 4.
Does it just keep going 1 to 4,
Yep.
1 to 4, 1 to 4, 1 to 4?
And that's why you see there's 5. There's actually 5 steps on there.
Yeah, 1, 2, 3,
And they're
that's
just
what
showing you
I
one
have.
again, right? It's just repeating.
So you can't really see that real time unless you
No,
have.
it's way too fast.
That's what the lights
Unless you
on.
have,
That's why they're flickering.
Each one of these pulses is 25 milliseconds. That's how long it pulses.
That's a long time.
That's not a long time. That's not a long time. I mean, even impatient people would say that's pretty quick.
In order to register a thought, it takes 25 or 0.25
Yeah,
seconds.
so you can have 10 thoughts technically, but in one, anyway.
No, you have one thought.
So the other thing to note here about bipolar motors, just in general, okay? When we're talking about these steps, what we're talking about, when we think of an electric motor, if I apply power to an electric motor, it sits there and spins and then slows down and stops, right? A bipolar motor doesn't work that way, all right? A bipolar motor, when I apply that voltage, I can apply that voltage and leave it there, or take it away, it doesn't matter, it's gonna rotate the same amount. It's gonna go one step for that applied voltage, that's it, no more, right? And it's gonna turn and stop, right? There's no rotation, right? It doesn't free spin, okay? It pulses and it turns. In this case, 3.6 degrees per step. You apply voltage and you leave the voltage on there, it's gonna turn 3.6 degrees. You apply voltage and you take the voltage off, it's gonna turn 3.6
That's why it has
degrees.
to alternate through the steps so that it keeps opening and closing.
Exactly. So the controller is gonna pulse those steps so that I get a nice fluid momentum. It just keeps turning,
Makes sense now.
all right? That's how that works.
because each one wires.
Right? Not that this matters really for a service tech, but I just want you guys to understand a little bit, what's going on inside that thing. All right, that's what's actually happening. So all the crazy ideas you've had about taking a 12-volt battery and hooking up and trying to drive stuff, it ain't gonna work. All right, I'll save you some time and effort there. All right, but anyway, that is how it works. This is for Sporlins, but this is actually all Sporlin electronic valves. When we move to Danfoss, the sequence changes, and that's why when I use my SMA 12, I gotta wire it. I gotta reverse 2 wires, right? Because it doesn't work this way. But this is what Sporlin has identified as their standard. So they're sticking with this so far. There are no exceptions. Here's something else about CDS valves. Because I got large and small, right, and I learned that with my 3 different sizes, I can remove the wire that goes to the motor on my small valves. It is built in on my large valves.
Trash.
It's harmonically sealed on the large valves, all right? So just keep that in mind also. That's an advantage and a disadvantage, all right? The advantage is if I have a problem with the wire, I can just replace the whole wire, right? That's the advantage. Disadvantage is that plug's been a problem, all right? They've changed the style of plug because it was possible to misclock it, to plug it on so that the red wire went to the black port, right? That's what I say about misclocking, right? You could be off by 90 degrees, right? You guys are aware of this, okay? So new valves coming out have a tab in them that prevents that, right? But that's a change, which means if I order a new cable for an old valve, won't fit. Right? So we've got some disadvantages there. One, because we can disconnect it, things can go wrong there. I can get moisture in it, those connections can go bad, I can misclock it, I can have a new one that doesn't adapt to the old one. Second thing to note here is all of these bodies will thread onto all of these motors. What?
No.
It is possible. Right? You may need an adapter, but it
Oh,
will actually
I was gonna
fit.
say,
I can adapt to anything.
yeah, I was gonna say, 'cause I went
With a authorized part. Not something you made in your house. The other thing about CDS valves are all of their motors do unscrew from their bodies. So we can replace the motor without soldering out the body, right? That's a huge advantage. The downside is there's nothing inside the body we can touch. We can't open it up. It is hermetically sealed. If we open it up, it ain't gonna never work, right? So it's one of those take apart for science, but not to run again.
Take it apart after you got
Yeah,
done.
just to know what's going on.
So you thought,
I hear you. All right. The other thing to note here is that they're all angled the same way. They all have the exact same angle, with the exception of CDS 16. CDS 16 has a special housing that gives us this weird 90-degree
I was
bend.
about to say, I've
Just
never
gotta
seen
be
one of those.
different.
All right, everything else is gonna have this, I don't know what it is, 30-degree offset, 40-degree, I forget what it is.
32 and a half.
Yeah, there you go.
He measured it.
All right, all the rest are gonna have that offset. All right, now, what if I have an A8 valve and I want to install one of these? Could I?
Yes.
Yes.
You can.
Yeah.
I watched the video on it.
All right, what if I've got Sorit?
YouTube, yep.
Could I install one?
Yeah, it's a,
Yeah.
it can store it to CDS.
Well, where are you gonna put this? Yeah,
Part
it's the
number
same.
11057.
Yeah. So the point is, yes, they make an adapter kit for both conversions.
Yes.
All right, I can actually drop a CDS to replace a Sorit or an A8.
That's so they can sell you new valves.
Or A9 even, because that's the same frame as the A8.
Yeah.
We got the valve, let's talk about how we drive it.
With one of those.
So, yeah, we cannot drive it with a 9-volt battery, right? We know that.
That looks a little more complicated than 9-volt battery.
So I gotta have something that's gonna pulse, right? It's gotta send the pulse signals. It's gotta also know the steps, how many steps I have to operate with. And it's gotta know how much to open or close, right? Those are the basics.
Could you
Okay.
technically do it with 2 batteries, like pulsing at that? Like,
Since unfortunately it's 4 wires that are set up in 4 different wire combinations.
right,
You gotta pulse them in 25 millisecond increments.
okay.
How long and how?
So, yeah, I mean, yeah, would it be physically possible to have 4 guys each with a button and, you know, maybe, you know, you guys practiced a whole lot, but, yeah, you're not doing that by yourself in a rack house at 2 AM, unfortunately. No matter how badly you need that thing open. That's not gonna work. All right, so I'm putting this guy up here for just a minute, and the reason why it's here is because one of our customers used this, and they're still out there, a bunch of them. So I just want to talk about how they work and how we're going to maintain this. This is from a service side, not so much startup. You guys are not installing these, right? Because you may be taking these out and installing something new.
Yeah, we used to
Okay,
use those as
so this was Sporland's first attempt at controlling their first valves. All right, it's called an IB board. That's the name of it, IB. All right, and the first ones, you will not find the letters IB anywhere on it. You will only find model numbers on it. It's very nondescript little green like piece of electronics. Okay, not much going on there, but it's a little square. And anytime we find this, what we're gonna find is could drive a TXV. It's possible. All right, our customer didn't use it for that. Our customer used it for EPRs. So we're gonna use this with the CDS, and that's why I tied it in here instead of with the EEVs, right? Because it can be used for that, but none of our current customers do. Right? But our customer absolutely uses this for the EPR. Okay. Now, if you notice, of all of my wiring on here, in order to control an EPR, I gotta have an input. I gotta have pressure, if I'm gonna control it like a regular EPR, or temperature, and we'll talk about the difference between those two control strategies in a minute, right? And if you notice on this board, it has neither. Okay, it has no input as far as pressure or temperature. What it has for an input instead is a 0 to 10 volt DC signal or a 4 to 20 milliamp signal. That's it. Okay? Which means something else is telling it
Nope.
how far to open, and it's just opening the valve that far. All right? So if we think of it this way, my EMS system can say, I should be opening my valve 20%. But it can't, this old Novar EMS stuff couldn't open a valve, had no way to move a valve, right? But I can tell something 20%, so it will tell this guy 20%, and this guy will drive my CDS valve open 20%. That's how it's gonna work. Now, here's the other side of it, okay? Now, this is a fairly rare Novar board. We just don't see this very often, all right? Me and Ian ran into this being used completely differently a couple weeks ago. There was a glycol set up that had valves that switched between chillers,
Yep.
open and close the valves, certain percentages. Right, we were using it for that.
Like Mason valves?
Automatic bypass valves to go from one chiller to another chiller.
With the same glycol loop.
With the same glycol loop if the first chiller lost capacity.
Right,
Depending on the amount of capacity lost, you could open up that valve a certain percentage.
right,
So
so
lost a couple compressors.
this device is called an analog output module, AOM. All right, now, most of our outputs with Novar or Emerson or Danfoss are digital. They're on or off, right? Open or closed. Right, but what if we want to send a percentage? That's an analog output, percentage, right? So this is how Novar does it with an analog output. Once again, this will send 0 to 10 volts or DC or 4 to 20 milliamp, doesn't care. It'll do either one, right? But it can tell something to go to a percentage. So we can use this analog output module to also control pulse width modulation.
Yep.
Oh man, I'm talking back to like week 2, right? But that means digital compressor. I can load and unload a Copeland digital compressor with an analog output module. Because I can tell it 30%, and it will say 30% of 20 seconds, turn on. Right? Okay, I can do that. I can dim my lights 70% with this, right? In this case, all I'm doing is sending a 0 to 10 volt signal, and it's direct. So 0% is 0 volts. 10% is 100% is 10 volts. Right? So add a 0 to your voltage and that's your percentage. Pretty simple. Alright? So if my EPR is not functioning like I expect, I've got 2 parts to diagnose. The first one is my Novar system telling it the correct percentage? Then the second one is the board telling the valve to open that percentage? Right? I'm going to troubleshoot the valve exactly the same. I'm going to put my SMA 12 on it, right, and see does it open and close. If it does, then my problem's with my controller. Right? Do I need to zero these? Yes.
Yeah.
Right? Right? Like any other stepper valve, I'm going to have a 10% overdrive at 0 automatically built in. So every time that I tell it to close and defrost, right, that valve's going to turn to 0, and then that board's going to tell it to turn 10% more, right, to try to drive it fully closed in case it was off a few steps. It'll hit 0 and stop. And then when it comes out of defrost, it will know I was at 0.
Is that the same thing across different manufacturers telling the same valve to do that? So for example, we have a Novar board or we have a Sporlan S3C, both communicating to a CDS-T7.
Both are going to drive 10% beyond
Both of
0.
them, because whoever's programming on the Novar side, whoever's programming on the Sporlan side, knows that they have to program that in, or?
No, good point.
Because
My
the
EMS
valve
system,
is being driven.
my EMS system is not telling it to overdrive
Right.
unless it's controlling a module itself that drives.
So like on this Novar, for example, if we're controlling a CDS-T7 through Novar, through that driver right there.
Yeah, it's just going to say
Novar
0.
would have to program.
They're not going to say go to minus 2 volts, right? It's going to just say 0. This board is going to, that board is then going to interpret that 0 and drive it over 10% beyond what its last count. It's gonna count down to 0 and drive it 10%, try to drive it 10% more times. So it knows it's at 0. That's gonna be it's gonna be in the valve driver itself that's doing that.
In the board itself, but
Yeah.
what I'm getting is every board manufacturer does that.
Yes,
Okay.
right. So modern Novar, right, 1081s,
Yeah.
right, XIO 1081s drives a valve itself. It's a Novar component, right? It's built into that program to drive it 10% too far.
So it doesn't matter if it's a Sport
Correct.
SRC controller or a
Correct.
Novar 1081. They
Correct.
all do it.
They're all gonna do that, but they're only gonna do it when it goes to 0.
Right.
So if it never goes to 0, in the case of like a subcooler
Yeah.
that doesn't go into defrost,
Right.
right, we got programmed it to go to 0. Okay, so it can do it. Right, that's all CDS, I mean, not just CDS, that's all bipolar stepper motors,
Okay.
valves, period.
What, probably a dumb question, but what else are you gonna see as a bipolar stepper valve outside of an EEV and an EPR basically?
Yeah.
Outside of the CDS, you know, and.
So any valve that you have can be replaced with these. We haven't seen it, but there's no reason why we can't be controlling the A9 valve that's pumping up the receiver and with a holdback valve in play, right? There's no reason that can't be an electronic valve. There's no reason. We just choose not to, because it's not worth the expense, I don't know,
Okay.
whatever. They just haven't yet. They will. It'll happen, right? Any valve anywhere can be this,
Gotcha, okay.
right? I could have 2 of these valves instead of a 3-way valve,
Yeah.
right? I could eliminate every solenoid I have with one of these,
Yeah, okay.
right? Yeah. And eventually, that's what I expect. It'll probably happen, right? We're not there yet. So, before we move on from this control, couple things to note about this version. Hey, what,
Chad snapped one.
you ain't go off the wall, or off the shelves? Nice.
Well, that way you can actually see it, like when you.
Which one we got? Okay,
That's an IBG though.
I'm about to go there, right? Thank you.
Yeah, okay.
Did everybody get a look at that?
No, not yet, you took it from me.
All right, couple things I want you to note on here. There's a set of toggle switches right here, dip switches, little tiny dip switches, all right? There's jumpers here, okay? If you look at my drawing,
No.
nope, I got either one, right? Okay, that's it. All right,
Don't be a dipswit.
so what's going on here, on my ID, if you notice in the title there, it says ID 1, 2, 3, and 6. That's 4 different boards, right? How many steps is this board gonna turn my valve?
200.
Depends, depends
Well,
on the
we don't
version.
know, yeah, it's whatever they program in the IC.
It depends on the, it's not programmable, it's burned into the board.
Well,
So if I need 2,500 steps, I gotta know, I gotta buy an IB1.
Or take that IC.
If I need 6386, I know I gotta buy an IB3. I gotta look that up, and I gotta get the right IB.
Yep.
It's not programmable, all right? So that's what we actually have in our stores, is this, okay? So when I'm replacing that as a service tech, when that goes bad, or I change my valve,
Does this one have the ability to do 0 to 10 volts? 'Cause
Yes.
That one, okay, it's just.
yes, yeah, this will read 0 to 10 or 4 to 20 milliamp, right? But it's gonna be burned into it, its steps,
Right.
all right? They're not adjustable.
That's programmable.
We have like 1 million of those, by the way.
That's programmable.
That is not programmable.
That one.
I'm gonna get there in a minute. You're taking the punchline, Chad. You're ruining the punchline, man.
I was just RTFMing, bro.
All right, so, but this is what we need to know as technicians, right? Is that board is specific to the step count, okay? So if I replace this board, I gotta match the step counts of that board, right? If I change my valve and I change the steps, that board will no longer work. Those are the 2 main things I need to know about that, right? The board we're passing around is a version of this. It's a later version. It's called an IB-G. All right?
Gangster.
It is a universal board that will replace all of these.
Chief one, that's what we needed.
Right. So as a service tech, I don't want to carry 4 of these for the off chance that I might need one. I'll carry a G, right? Now, what's different about it? I got dip switches that I can tell it how many steps,
Oh, I like that.
right? I've got a jumper that will tell me how many volts.
Yeah.
I know
Okay.
there's some
That could be an
this
SMA.
process around it.
That could be what?
That
Yeah.
could be your SMA.
Yes.
Yeah, it's an Arduino.
All right, did you guys just hear what he just said?
Soldered that.
Did you guys, no, this is really important. This is a very useful service tool. All right? So when we're troubleshooting a valve, any electronic valve, all right, the first thing we're gonna do is connect our SMA 12 to the electronic valve and see if it moves, right? Well, what we're actually doing is simulating a controller. Is that not a controller? If I send it a 0 to 10 volt signal, can I not tell it to open or close that valve
Yep.
based on its number of steps and the correct voltage? Yeah, I can.
But you gotta have something.
Would that work in a pinch to hook up a 9 volt battery to that guy
I'm adding it to the.
and leave a case run? Yeah,
Yeah.
it would.
Or a signal generator.
Or a signal generator, right?
Could you like fully set it up for condenser fans?
What would that board be called?
Could you do what?
Fully set it up for like condenser fans,
We have to
say,
watch on the shadows.
I forget what board.
So your condenser fans are using just a 0 to 10 volt signal. They're not bipolar.
Oh,
That would be a bipolar motor stepper. It would be used for any electronic valve that's bipolar.
So, if you
But yeah,
lose,
what you're talking about.
for example, you lose your S3C,
Do you have a
right?
signal
That's
generator?
driving your
Or
CDS.
just a 9-volt
Correct.
battery?
You could
You
take
just
a
run
9 volt
whatever,
battery and
right.
one of those,
9
hook
volt
up
to-
your CDSC7 to it.
Yep.
And then hook your 9 volt battery up to that.
Yep.
And drive that valve off of
It'll go to
that
90%.
setup.
Yep.
And it'll go to 90%.
Then you can unplug it and leave it.
And then you walk away. So if you don't have your SMA, that's the move that you can do.
Correct.
Okay. So,
It's-
but it's
it's
not
smaller,
gonna
too.
sit there and
Hey, you don't have
modulate,
to
it's
leave-
just
you don't
gonna
have to
go
leave.
9 volt.
You don't have to leave it
You don't
either.
have to leave your SMA in there with this.
Well, you don't have to leave your SMA anyway, you just don't
stay
leave it up and walk
unplugged.
away.
Oh.
But a 9 volt battery in that is a hell of a lot cheaper than an SMA.
Yeah, sure.
Now granted, a 9 volt battery in that, what you're saying is only gonna go to 90%.
And I gotta give it 24 volts to run it. Don't forget that part
You
too.
don't have to-
Okay, so an SMA is still doing more,
Yeah,
but.
and your SMA 12 is showing you the lights lighting.
Yeah.
You know, and whether you're checking your
So-
voltage.
so
But
this
you can do that
is-
with your meter, just the same.
So this could be used as a diagnostic tool or
Absolutely.
a get me out of a pinch thing.
Yep.
But it's not the end all be all to replace an SMA 12.
Correct.
Okay, that's what I was
Correct.
getting at.
Now, if I've got to if I need to set that valve at a rather precise setting and leave it instead of 90% or 100 or 0, yeah, I need 30%, right? With my signal generator, I can send it 3.33 volts and it'll set it at a third, right? I can leave that valve very accurately positioned. Whereas with my SMA 12, I'm winging it on time, as we just talked about.
Getting it close.
6 seconds is roughly halfway, right? Well, 5 volts is exactly halfway.
Right.
Yes, sir.
So on that, Sporlan, so like this subcooler, right? Sporlan valve driver, the little Sporlan box that says pressure, whatever. If one of those were to go kaput, we could
Yes.
put that into play since we're getting our 4 to 20 signal from Novar. Plug in our communications on the 4 to 20, plug in our
You're
input
not getting
voltage.
420 on from Novar on the Kelvins, Kelvin 2s.
How's Novar telling it to overdrive at night then?
It's just a digital close.
Novar's is.
It's built into the,
But we'd be able to put that in place of that switch temporarily.
so you could replace your subcooler control, you could replace the EEV, but not, I mean the EPR, but not the EEV, because it won't adjust to superheat.
Okay.
We could flip.
So even though that is the general one, we are fairly limited in the application. Okay,
Yeah, because it doesn't have an input or an output for temperature, right?
gotcha.
Now, that, however,
Yeah.
okay, so these guys, we're kind of familiar with this. This is, when you hear me talking about the Kelvin lineup, the Kelvin 2s,
Yeah.
right? All of these are Kelvin 2s. There's a generic Kelvin 2 that's got some really basic PIDs in it.
Yep.
These Kelvins are all specifically engineered to do something specific. I don't know if you guys have seen this chart before. The reason I've got it up here is because it's a good segue on what different ways to control our EPRs.
Yeah.
But we use it constantly. We see this for subcoolers,
Yep.
right? We see this very regularly for subcoolers. And if we look at the mechanical subcooler one, the version right here says subcool on it. That's the one we're actually using, right? But this guy can control any of these electronic valves. We can set the steps, right? And it can take an input and an output. So if I had an S3C go to in a case that was controlling an electronic TXV, oh,
You could put in one of those.
and you could run that case, right? Until you got your S3C sorted out,
Add it to the list.
right? You don't have to leave the case down and out. You can put one of these in and it will drive,
Add it to the list.
right? Now you, yeah, because you're gonna land your pressure and temperature, it's gonna calculate superheat. You tell it what its target is, you just program that in.
So you could also put an S3C in place of one of those.
Oh, are you saying add those to the
Absolutely.
list?
Yeah.
Oh, no, they're $1,200 difference.
Yeah, but they will work.
I just bought two.
But they will work. Now, the reason why, now, since you guys are talking about field tools, right, the reason why I bring that up is because I have seen techs mount this to a board. Actually, a piece of wood board, right?
You might as well skip it.
Add a transformer, so they've got 110, they can plug in, and yeah, you can drive any valve, and you can set it and do whatever you want, and see if the valve does what it's supposed to do.
That's a really
Right.
good tool.
Yeah, sure.
Well, yeah, but we
This is
have
probably
really
your
expensive
least
tools.
expensive way to build a very complex SMA 12. That's, gives you far better.
I mean, the
Control.
estimates are like
Hey, you know, I mean, you couldn't get from the
Not our
360
price.
to
What's that?
480.
The estimates are $1,400, not our price though.
Right,
They're like $500 our price.
yeah.
I love that.
But cheaper than an S3C by at least half,
Yeah.
maybe even more than that. And it will take your transducers and your sensors that are already in place, so you can evaluate them as well, right? Okay? But the reason why I got this slide up here is to talk about EPRs, right? Because that's what we're discussing. Remember that, EPRs? All right, using this electronic valve setup as an EPR, we notice there's two different Kelvins. One that is running off of temperature, one that is running off of pressure. So let's talk about that. All right, if I'm gonna use an electronic EPR in place of a mechanical EPR, it's natural to assume I'm gonna add a pressure transducer and I'm gonna maintain the same pressure I would dial into that EPR very precisely, right? Does that make sense? And I can do that. I can do that.
Yep.
But that's not how they're normally being used, right? That is possible, and with an S3C I can program that if I want to, right? But that's not how they're intended to be used, okay? When Sporlan developed this concept, they didn't even develop that. They developed the temperature side first, and then later added this because everybody asked for it. All right, so let's talk about the temperature side. So instead, my EPR dictates the pressure in my evaporator. We're using, technicians are using a PT chart to convert temperature to pressure. My engineer started out saying I wanted a specific SST. He didn't say pressure,
Yeah.
right?
Yeah.
We kind of assumed that. Right? So that means when I set up my EPR, I don't have to control it off of pressure. I can control it off of temperature.
Right.
Now, I got all kinds of ideas now. So one idea is to put a temperature probe in my evaporator. If they say they want a 13-degree evaporator, I'm gonna measure that evaporator temperature and give you 13 degrees. Take middleman out, take your PT chart out, right? No longer worry about midpoint. 13 degrees, 13 degrees, perfect, right? That's how this started. Then, the next logical step was, well, but if that's not giving me the supply air temperature I want, because I've had some air infiltration, or somebody just stocked a case, then maybe I want to open that EPR a little bit farther, get a little cooler, and get my temperature correct. So now we're going to move that temperature probe into our supply air stream instead.
We have one of those in the shop.
Do what?
We have one of those in the shop, two of them, actually.
Yeah, for temperature?
No.
No, probably pressure. So anyway, that was Sporlan's idea when they developed this. was to control this off of coil temp and then supply air temp, all right? That has definitely spilled over into engineering today. So when we look at very advanced control systems that are driving these valves, they're gonna use some of that. They're not necessarily gonna use all of that, but they're gonna use some of that. That's gonna come into play. They're gonna say, I should be able to open this EPR more than normal if my supply air temp is higher than normal. Okay? If my supply air temp drops dramatically, I'm gonna close it farther than normal. All right? In other words, if my case gets dirty and that supply air starts getting really damn cold, I don't need my suction to be as low. I'm gonna go ahead and raise it. All right? That'll help my freezing problem too. Okay? So I'm no longer gonna have a fixed pressure, it's gonna move. That's the point, based on my temperature. When I need more, I'm gonna get more. When I need less, I'm gonna have less. That's the temperature control idea. All right? That's gonna give me a more steady temperature of my product, which is really the whole point.
Right. It's gonna give you more unstable suction pressure though.
All right? It's gonna cause my suction pressure to be more unstable. Okay? That's exactly what it's gonna do. All right? If I'm controlling my compressors with digital unloaders, I can eat that. It's not a problem.
Yeah.
If I've got my compound cooling rack and I'm down to 2 compressors because my rack keeps getting smaller and smaller because I got more efficient cases with covers on the tops on my glass doors and all that good stuff, that's not so great.
Right.
Okay? Understand that's what's happening. All right? So generally, when we're designing, controlling this, those are the 2 ideas we're going to have: pressure and product temperature. All right? Those are going to be my 2 variables that I'm going to be competing against in design strategy. Right? That I've got to navigate as a technician. Which am I using? Right? Because I'm going to get 2 very different things. If it's set up for temperature and my suction's moving, that's normal. If I'm set up for pressure and my suction's moving, I got something wrong.
Yeah.
Right? Does that make sense? And that brings us to combining both ideas.
Yep.
All right? So when we start getting into S3C, they're not the only ones, KV2, right, that have figured these ideas out. Who makes S3C?
Sporlan.
Sporlan, right? This is just another evolution. They took those 2 controllers and said, what if we just smashed them together? Right? Now I can write a PID that prioritizes one over the other, that uses both ideas. So I can predict into the future what I think it's going to do based on pressure or temperature, and then cause the valve to react so it'll be there in that point in the future. That's what it's doing, right? That's all it's doing. So when we set this up, we've got an opportunity to choose, or the engineer's going to specify which of those combinations we're going to use, because now we have 3 combinations. We have temperature, we have pressure, and we have temperature and pressure. All right? Who knows what's going to be the 4th? Isn't it exciting?
S4C.
All right, so that's our control. Yeah, a little sarcasm there, sorry. Wipe that off my chin. Pressure seems to work pretty damn good. All right. So one piece I did not cover in here, and I'm just realizing as I'm thinking, is floating suction.
Something new to that.
So yeah, before we get to that last slide, let's talk about that. What is floating suction, and what's it mean to us? So our customer used floating suction heavily for a while. They have abandoned that idea and are taking it out as they find it, but they haven't removed it across the board. They haven't gone into every store and removed it. We may walk in and find it. All right. Other customers are still using floating suction. All right. So what is floating suction? Well, the concept is I'm going to take the 2 coldest evaporators in my store, 2 coldest circuits, all right, that are not walk-in boxes. Walk-ins are exempt. All right, take my 2 coldest evaporators that are in the store, and instead of using my EPR to control their temperature, I'm going to unscrew my A8 all the way out so there's no EPR. It's running wide open. Well, isn't that going to cause problems, Matthew? Well, No, because we're not gonna cycle them. We're not gonna let them hit the cutout and shut off. All right, what we're gonna do instead is, as their temperature drops, instead of letting the temperature drop and turn off that circuit, I'm just gonna raise the rack suction pressure. That's gonna lift its, just like its EPR was holding it, right? Suction pressure is gonna go up. Its EPR is wide open, so its evaporator is also gonna go up. It's gonna warm up. All right? That means my suction for the entire rack is now floating with the temperature of that case. When that case starts to warm up and it gets too warm, I'm gonna pull the whole rack back down to cool it down.
Isn't that still cycling in some form though? Because you're gonna have to adapt to the change.
Let's say that again.
Totally on low.
You're still cycling, you still technically be cycling because you're still trying to adjust and raise that pressure up.
You're low.
You're not staying at a constant cycle.
Right. So his question is because I'm changing the set point of my suction group on the rack, is that gonna cause my compressors to actually cycle?
No. Well,
Can.
No, well, that's why
Can.
it's stupid, but in theory, no, it shouldn't, because you're only floating your suction when it's, or when it makes sense to float your suction in low load situations and stuff.
So it's gonna be a small number of PSI, it's not gonna be huge, right?
Yeah, 'cause-
Let's say I've got a 6-degree rack or 10 degree, I guess would be more, or sorry, 10 PSI rack. 10 PSI, right? I'm gonna let that pull down to 6, I'm gonna let that go up to 12, okay? That's kind of a normal swing. When I float, I'm gonna allow that to go up to 15, maybe 16, no higher, right? So I'm gonna spend a lot of time at 13, just a little higher than normal, right? That's traditionally what happens. Is it gonna cycle more? Yes, actually it will, right? There's no way it's not going to. It's not a huge amount, but it will cycle more, okay? Which kind of defeats the purpose and one of the reasons why everybody's walking away from it, right? The other problem that I have is sometimes that case that I'm controlling doesn't need refrigeration, but that one does. It's not on that circuit, it's on a different circuit,
It needs a lot of flexible combiners, a lot of.
right? So that one starts to run warm, right? And that's an unintended consequence. We didn't want that to happen. That's the real problem with floating suctions, is that does happen, right? So when we can see that on TA, when the whole store warms up and the store goes because I'm floating my suction, but I'm saving power, that's when they said, oh, this isn't what we wanted. They didn't realize it. You know, everybody's saying it, but it wasn't real to anybody until they saw that happen.
That's
Right.
like every PSI you raise your rack suction pressure is like, I heard it could be upwards of like $10,000 a month or whatever they save in electric.
Depends on the horsepower of the rack, but yeah,
It's
right.
ridiculous.
It is a huge amount of money. So they were saving giant amounts of money, but they didn't realize the product integrity that they were selling wasn't as
Yeah.
good, right? But when they got TA, they could truly see the impact, and that's.
Sometimes I
that
see
could-
like ridiculous set points on some of these racks that are like, you know, particularly 407 racks too, but you know, like 4 PSI set points on low temp
Yep.
racks and all this other stuff when really.
Minus 27s, yeah.
But it's not, they're not even that. I'm like, you guys could raise the suction pressure up like probably 3 PSI. Like, you can make that 8, like,
Yep.
you know, and still be completely within spec. So that obviously they're covering up for an issue, but you know.
So the last piece to the floating suction before I leave that, remember I said 2 circuits, right? The reason why we run 2 is because one's gotta go into defrost. So we're gonna control off of one case, one circuit, until it goes into defrost, and then we switch to the other. Then we run the other until it hits defrost and we switch back. So when you walk into a rack and you see floating suction and it lists the 2 circuits, those 2 EPRs should be wide open, right? Those 2 EPRs should be completely unscrewed, and you should be controlling off of one or the other. Now, the other downside to controlling that way is I may have 6 cases on that circuit. When I say I'm controlling off of that circuit, what am I controlling off of?
The sensor.
I'm either controlling off the average of all 6
Or one.
or 1, right? In the case of Novar, it's just 1.
Yep.
So I'm running the entire rack off of 1 case.
Yeah, that's
Well,
dumb.
we can think of lots of things that could go wrong with that. Right? I lose a fan motor, right? You know, whatever. The entire rack changes, right? So anyways, that's the disadvantages of it. The advantages are what Corey just said. Power, man, they save a lot of power by letting that suction drift up. Floating my discharge, there's a couple different ways to do that. the most energy efficient and the most common idea is to get subcooling out of my condenser. So to do that, I've got to measure my drop blade temperature and pressure, and I can calculate superheat. Rack controller can do that. Do what? Subcooling, excuse me. Subcooling. My rack controller can do that. It's an easy program to do. Now, in order for that to work, if you remember our receiver class, I had to bypass, I gotta be able to bypass my receiver. So that piping has to be there. I can't just convert any store that I want and keep my subcooling.
Yeah, so like, I took a picture of it, because that was the first time I saw it. But it says attention, floating FHP, which I'm assuming floating head pressure. This rack has been converted to operate with floating head pressure, like with all bold underlined. The subcooler EPR is set to evaporate at 35, the large set come in at 85, blah, blah, blah. The controller input is how the drop leg temperature sensor,
There you go.
whatever, do not, please, and then highlighted, please do not alter these settings.
Yeah. So they didn't use that, obviously. They never
Yeah, I
ran
just
that.
thought it was weird when I saw it, so
I think that was just a terminology thing for using the VFD.
that's what I kind of.
So the first, and this is not a VFD class, we're not gonna get all into that.
Yeah.
But the first iteration of VFDs that Walmart used calculated subcooling and ran off of subcooling. 13, 17 degrees of subcooling is what they were looking for. They only did that for a very short period of time,
I wonder why.
6 months, something like that. And then the VFDs, do what?
Oh, no, I was like, I'm so glad I take pictures of like literally everything that I
Yeah.
question. I'm just like, okay.
So then the VFDs went to controlling off of TD, and that's how they all are today, if you find it working, it's working off of TD. So I'm thinking that that tag that you're reading there was that first attempt to actually use subcooling off the VFD. It's not really a floating
Yeah, it's
discharge,
not.
right? We're not changing the target of the discharge. We're just telling the VFD to ramp up and down until I have this temperature of subcooling. Yeah, and if we, you know, I think this is our last public store that we're doing it all. If we get back into stores that are using hot gas, I will do a whole class.
I guess.
Well, hot gas, but we ain't running into it much. So we have completed going through the cycle. Let's do a very quick lap through the cycle and any questions that you guys have. I got all kinds of time for Q&A. Let's just run through it one last time. We started out with our compressors, right? We talked about the suction header coming into this with our accumulators. We went into the compressor, we came out on the discharge, we hit our oil separator, we broke off and went through the low pressure and the high pressure oil systems with the regulators on the compressors. We came out of there, we went through our heat reclaim setups. All right, then we came out of there and we added a few more valves here. We added another 3-way valve for a 50% split, and we talked about the solenoid version of it and the check valves on the other side. We went through the A8 as our holdback. We went through our A9 as our hot gas pump up to our receiver. We brought our refrigerant in. We added a bypass valve here and talked about that. All right, we got our liquid coming out of here. We're going into our dryers. We went through our sight glass, which is on the other side of our subcooler normally. We went through the subcooler itself and all of its different configurations. Then we came up into our liquid header, came down our liquid header and went through our solenoids, went through our expansion valves, went through our distribution system, went through our evaporators, went through our EEVs and EPRs into our suction header, and that leaves us back at our compressor. Good?
Thank you.
Now we get a test, and whoever fails.
Your
your
test,
call.
your test is your service calls.
No.
Show me how much you learned
The people with the lowest.
by
score
being
get
more
the most
proficient.
calls. That's how it goes.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.